All right, now we want to talk about, again, this is a review, we've spoken about this before, the solution process called solvation, where literally these polar molecules of water, right, this is hydrogen, oxygen, hydrogen, partially negative, partially positive, and it literally pulls the salt apart. So sodium plus chlorine negative, and these water molecules literally pull apart the sodium and the chlorine and put it into solution. So if something's going to go into solution, it has to ionize. If it doesn't ionize, it's not necessarily going to go into solution. Now, a big exception to that is sugar. Sugar doesn't ionize, but it goes into solution. But it's a non-electrolyte. It does not conduct electricity. Water does not conduct electricity, and sugar in water does not conduct electricity. A sugar solution doesn't conduct electricity, water does not conduct electricity. If I dissolve sodium chloride into water, that will conduct electricity. That's called an electrolyte, as opposed to a non-electrolyte like sugar. A weak electrolyte would be mercury 2 chloride. And in the book, there's a great picture that shows you that, and it's figure 1510, conductivity of solutions, okay? And that's really what I'm going over right now. Now, for something to conduct electricity at all, it has to be in the ionic state. So for instance, if I take water, let's write it HOH plus HCl. That's going to make, let's do it this way. That's going to make H3O plus charge. It doesn't really go as a proton, as an H plus. It's really, that's called the hydronium ion. That's going to be big. Hydronium ion. H3O plus charge. Plus Cl minus charge. Yes? This will conduct electricity. Yes? That will conduct electricity. If I take ammonia as a pure substance is polar just like water, but it won't conduct electricity. But if I dissolve some of it in water, it will become something other than this. I'm going to erase this. It will become, I'm going to put a hydrogen there, and it will become NH4 plus 1 charge plus OH. Okay, now the substance is called ammonium hydroxide, but it's really in the ion form dissolved in water, and that will conduct electricity. If I take ammonia, which is the most soluble gas, incredibly soluble, very soluble, number one. I put it in water, I'll produce ammonium ion and hydroxide ion. And that will conduct electricity. And that's right in your book. Those are strong electrolytes. Again, the weak electrolyte, mercury 2 chloride. Okay, let's see what else. Water of hydration, we talked about that. It says the water contained in a crystal is called water of hydration. It's a hydrate. So, concrete. The reason concrete is so strong is because of water of hydration. So if I take copper 2 sulfate, which is white, off-white, and I covalently bond 5 water molecules. This is called copper 2 sulfate pentahydrate. This is a hydrate. Understood? It's a hydrate. It's a hydrate. Concrete is also a hydrate. It's a hydrate. If you take the water out of concrete, you get dust. It falls apart. Falls apart. So concrete is a hydrate. So there's a lot of hydrates that are very important. As long as concrete stays moist, doesn't dry out, it'll be very strong. Very strong. So hydrates are extremely important for everyone. And you can change the color if you get rid of the water. There's plenty of examples in the text where if I get rid of that water, I'll change the color. Okay, I think it's a cobalt, it says. It says, let's see. It says another compound that changes color in the presence of moisture is cobalt 2 chloride. Cobalt 2 chloride. Cobalt 2 chloride. That's another one. And it says, as you can see from figure 5.13, when the paper is exposed to moist air, it turns pink because of the formation of the hydrate, cobalt chloride, cobalt chloride, dot, you put a dot, hexa is 6H2O. Cobalt chloride, hexahydrate. Cobalt 2 chloride, hexahydrate. Greek prefixes. Okay? And I think that's pretty much it. There's a few other things that you should read. Here's some things. Efflorescence hydrates. The water molecule in hydrates are held by weak forces, so hydrates often have an appreciable vapor pressure. If a hydrate has a vapor pressure higher than the pressure of water vapor in the air, the hydrate will lose its water of hydrations and effloresce. For example, copper 2 sulfate pentahydrate, that's right, that's this. Copper 2 sulfate pentahydrate has a vapor pressure of about 1 kPa at room temperature. The average pressure of water vapor at room temperature is about 1.3 kPa. Copper 2 sulfate pentahydrate is stable until the humidity decreases. When the vapor pressure drops below 1 kPa, the hydrate effloresces. Washing soda or sodium carbonate, decahydrate, sodium carbonate, decahydrate. So sodium carbonate, decahydrate, sodium carbonate, decahydrate. It says is efflorescent. As the crystals lose water of hydration, they effloresce and become coated with a white powder of anhydrous sodium carbonate. You have, again, more terms. Hygroscopic hydrates, make sure you know what those are. Hygroscopic. And one that's kind of cool, actually, is deliquescent. It says deliquescent compounds. Have you ever noticed the small packets of silica gel that are often packed with electronic equipment and leather goods? Although the structure of silica gel is not the same as a hydrated salt, it is hygroscopic. It's used to absorb moisture from the surrounding air to prevent damage to sensitive equipment and materials. Some forms are so hygroscopic that they become wet when exposed to normally moist air. These compounds are deliquescent, which means that they remove sufficient water from the air to dissolve completely and form solutions. A common substance that does that, very deliquescent. Deliquescent is the way you pronounce that. Sodium hydroxide. If you take sodium hydroxide comes in little white pellets. And if I just take some white pellets and put them in a dish, right? Put them in a dish in the summertime and just hang out, no air conditioning on. This bowl will fill with water. And the sodium hydroxide will dissolve. And you'll be left with a dish of sodium hydroxide aqueous. An aqueous solution of sodium hydroxide. Okay, it'll just be water with sodium hydroxide dissolved in it. It's so deliquescent. It says these compounds are deliquescent, which means that they remove sufficient water from the air to dissolve completely and form solutions. Okay, that's it. That's really it for section 2. Again, you should read, ask questions. I'm available. Send me an email and we can talk on Google Meet. Okay? End of video.